It's just like a smart sensor. It does everything that a human being would have done had it failed. This is the architecture. Internet of Things, all of you must be aware, is a network of physical devices, vehicles, appliances and other items embedded with electronic software, sensors, actuators and network connectivity that enables these objects to connect and exchange data without requiring human to human or human to computer interaction. Each object is uniquely identified, something like your Aadhaar card, so that they can talk to each other, but is able to interoperate with the existing internet. This is the block diagram. Any device, anybody, any service, any business, any path, any network, any place, anywhere in the world, anytime, any context. Now this concept or this architecture, when it is applied to ships, you get what is the autonomous ship. A fully automated ship on the engine side or the navigating side is what you see here. You have the navigation system, the maneuvering system, the machinery management system, propulsion system, power management system, alarm, all of these already automated. Now when they are all interlinked using the concept of IoT, then it becomes fully autonomous. So IoT applied to ship will be all these systems interlinked, and each one of these systems will be made up of subsystems. They in turn get interlinked, and this is what is the block diagram. You see on the top are all those systems for navigating. This. At the bottom, all machinery. Can you switch on this? Yeah, fine. So the top ones are all the engine room automation, ship maneuvering, navigation. The top one is the navigation part, and the bottom one is engine room part. And all of them are networked using routers, you see? And then they are connected to the central processor, then to a backbone, which gets connected to the SATCOM or VSAT. Now what you have to note here are these. These are the vulnerable points. Anybody can, once he knows the identity of the ship, can hack in, get into this, and control any of these systems. We'll come to it later. Now this is what I talked about, the situational awareness system. What is happening, what you saw before was what is happening inside the ship. This is a system which tells what is happening outside the ship. You have the high definition visible light cameras, the infrared cameras, the LiDAR and the radar. They are all processed using what is called a Kalman filter, which gives a clear picture of what is happening all around so that the ship can navigate safely. Now, the previous one you saw, the situational awareness system, not interlinked. Now the situational awareness system is fully interlinked. This makes it what the autonomous system is today. There are two types of autonomous systems. One is remote control, the other is fully self-controlled. This is the diagram. You have the mansion, the man on board, the navigator on board there. He gets all his inputs from these devices and controls the ship. This is a remote control ship. He gets all the inputs. He's sitting somewhere ashore and he controls it through the satellite. Then this automated ship, there is nobody either on board or at the remote center, and the computer takes over complete control. That is fully autonomous ship. And then the bottom one is a combination. You will see a little bit more of it. This is how the picture looks. The autonomous ship, there is no accommodation. That accommodation space is taken over by additional hatch. Now let's see the pros and cons of it. Short port stay, fast turnaround, no crew cost, hence lower operating costs, lower freight rates, no accidents due to human error or failure. We will come to this point once again. No more cases of criminalization of seafarers because there is nobody on board. No dependence on crew supplying countries. This is another good news for countries like India, Bangladesh, Philippines. And ship owner is in full control of the ships. Let's look at the cons. Vulnerability to cyber attacks. Anybody can get into the system, as I showed you. Increased piracy threats. Pirates are not dumb people. They are also advanced in technology. So as the technology advances on board, they are getting advanced and are able to attack the ships. Increased fear of hijack. You load a ship, a container ship in Nava Sheva for Felixstowe. It goes, it's a fully autonomous ship, there is nobody on board and there is no remote control. Somebody can hack into it, take it to Somalia, empty the containers, and then leave the ship there. So that threat is very much there. Accidents due to machine failure. The pros said no accidents due to human failure, but machines do fail. So there is a possibility of accidents due to machine failure. There is a remote control device somewhere at a control center which is controlling it. That is being manned by human beings. So there is a possibility of accidents due to error caused by human operator sitting at a remote control center. Increased scope for maritime frauds. No guarantee of cleaner and safer seas. Threat to employment opportunities for mariners. Search and rescue operations at sea becomes difficult. Potential danger to all manned ships, smaller crafts, fishing vessels, etc. in the vicinity. Safety and security issues for ships operating in conflict zones. You see, during the Iran-Iraq war, we used to go right up there to bring oil for our industry. One of the Shipping Corporation of India ships, which huge marking on the deck, India on the sides. Mr. Saxena will be able to bear me out. It was bombarded. It was hit on the bridge. Bridge got damaged. But there were people on board. So they were able to navigate it safely to Dubai for doing the repairs. What would happen if there is nobody on board? That is what I'm trying to convey. And above all, no legal framework in place as yet. If you see any cargo ship, there will be at least about 50 to 60 certificates on board. So many regulations have to apply. But today, we don't have any regulations in place for an autonomous ship. So how relevant are these rules? SOLAS, safety of life at sea. If there is nobody on board, it is irrelevant. Somebody suggested it should be SULAS, safety of other lives at sea. Colrane, rule number 5 says, look out, both by sight and hearing. If there is nobody on board, who will do it? Marpol, you have that 15 ppm machine. If it malfunctions and allows the bilges to be emptied at sea, who will be answerable? GMDSS, when there is ship in distress, it is a duty of all the other ships to go to its help. But you have on an automated, autonomous ship, situational awareness system. Instead of going to its help, it will try to run away because it thinks it is an obstruction. So that is the problem. STCW, Standards of Training, Certification, Watchkeeping. If there is nobody on board, what is the watchkeeping? MLC, Maritime Labour Convention, nobody on board. So all these regulations are applicable only to manned ocean-going vessels, need to be rejigged, reconsidered and rejigged by the IMO. But developments are taking place mainly in the European countries. Rolls-Royce is the leader. They, along with Fin Ferries, which you will see later, have already launched a ship. They call it Advanced Autonomous Waterborne Application. European Union, or Union, is already working on this to try to assess the technical, economic, and legal feasibility of operating an unmanned vessel during open sea voyages. Researchers in DNV and GL, they are busy trying to make relevant regulations. In Norway, there is a company called Yara. It is collaborating with Kongsberg, which is providing the technology. And this year, the ship is ready now. They're going to launch it. Initially, as fully manned vessel for some time. Then, remote control vessel. Then, totally autonomous vessel. China is not lagging behind. They are doing a lot of work to ensure that they'll have commercial vessels for the coastal region and also for the military sector. China has already allocated 225 square nautical miles of water and island somewhere near Macau, exclusively for doing this kind of research. So these are the main particulars of the ship MV. Yeah, I just put MV, but I don't think that nomenclature is correct because it is not a motor vessel. It is going to be an electrically driven vessel. So the length overall is about 79, length between per period is 72, molded breadth is 14, draft, fully loaded draft is 6 meters, ballast, draft and the ballast is 3 meters, service speed 6 knots, maximum speed 13 knots. Normally for a normal ocean going vessel, the service speed is 15 knots, but they are now, because it is just starting, they have pegged it to 6 knots. It's got a cargo carrying capacity of 120 TEUs. The propulsion is fully electric. The propulsion system consists of 2 azimuth pods and 2 tunnel thrusters. The battery bank is capable of providing 7 to 9 mega units of current. The battery also acts as a ballast. So there is no ballast water problem. No ballast water management is required. Automatic loading and discharging of cargo. Automatic berthing and unberthing of ship. And it's going to be confined to the coastal waters of Norway, that is somewhere near Trondheim. You'll see about it a little bit later. When did the journey start? It started way back, as I said, 200 years ago, when automation came on board. But it picked up its pace somewhere between 65 and 70 when UMS ships were introduced. At that time, we didn't do much to alter the officer and crew strength. It used to work with about 60 to 70 people on board, but it started getting reduced. Okay. Now, you have the vessels, which is about Indian vessels with about 28 on board, but I believe in the Far East they are running with 12 people on board, 12 officers plus crew. So it has been gradually reduced over a period of time, and now with an autonomous ship, there is going to be nobody on board. Even when ships are able to operate completely on their own, there will have to be somebody ashore who can take charge of it when conditions demand it. That means still people, the technology providers, are not absolutely sure of totally self-controlled ship. Different types of ships or ships at different stages of their voyages will, in all likelihood, require very different levels of oversight and control. For instance, a cargo ship far out at sea will normally need very little human supervision, with just a single person, commander or controller, overseeing many ships at the same time. But a vessel which is in congested waters, or for example, if it is crossing the Suez Canal, you will require a dedicated person sitting ashore to control it. When time comes to control large ocean-going autonomous ships from facilities ashore, the centers set up for such remote operations might resemble the Rolls-Royce Unified Bridge concept. This was introduced about 10 years ago, where you get an all-round vision from the bridge. That concept is going to be introduced, and you'll see a little bit more of it. This is how it will look like. Advantages as claimed by the concept developers. The concept developers are all the technology providers. The ships will be safer, be more efficient, be cheaper to run, have large cargo carrying capacity because there is no accommodation, offer lower wind resistance again because no accommodation, so it will become fuel efficient, and help ship owners and operators to respond to growing shortage of fuel. Challenges before the autonomous ship. There are many of them, but I have listed just 4 main important ones. Regulatory changes required to allow autonomous ships to operate safely. The underpinning word is safely. Insurance and legal liabilities related to issues in the event of an accident. Nobody knows what that is going to be. Cyber crimes and piracy attacks. So therefore there is an urgent need for putting in place for governing the safe operation of autonomous ships on high seas. The following agencies united. One is the AWA of Finland, SARUMS of Europe, Maritime Autonomous Systems Regulatory Working Group in the UK, and the IMO. Now we take a little bit of step behind, and then I was a little bit nervous when our friends were going to answer, because part of what I'm going to show, we showed, but then this is a little bit more than that.